In our previous lesson, we talked about solving systems of equations using substitution. Today, we're going to talk about solving systems of equations using elimination. This is a different method. When you think of an elimination, I normally think of something disappearing or being killed off. So if you look at these pictures, you got a picture of a Twix bar, some cauliflower, broccoli, and Sour Patch Kids. If you had to think of the things that would be eliminated first, would be the vegetables or the candy? I'm thinking with you guys, it'd probably be the candy. With me, it'd be the candy. So elimination would be the things that would disappear, that we want to go away. We might want the broccoli and the cauliflower to go away, but that's not what is actually going to happen the fastest. So if we look at this problem, if we want to solve this system by elimination, we've got two equations like we had before, but neither of these equations are solved for a variable, either x or y. So we have to use something called elimination. That means we want to eliminate one of the two variables. So we have to pick out which one we would like to eliminate. Well, if you look, we have 10y and 6y. We can't make those look alike very easily. But if we look at negative 6x and negative 3x, these two can look very similar, but we want them to have opposite signs. So we're going to multiply this whole top equation by negative 2. Because if we multiply by negative 2, then this negative 3x will become a positive 6x. Well, that will make those two x's be eliminated. So that's what we want. So, if we come down here and we distribute this negative 2 like this, negative 3x times a negative 2 is a positive 6x. 10y times a negative 2 gives me a negative 20y. And negative 16 times a negative 2 gives me a positive 32. Now we didn't have to multiply the bottom by anything, so what we're going to do is we're just going to keep those the same. So we'll rewrite the second part, negative 6x plus 6y equals 24. Now, these are stacked on top of one another. What we're going to do next is we're just going to add. Notice, our variables are lined up. The x's are with the x's, the y's are with the y's. So what we're going to do is we're going to just add like we were doing addition or subtraction when we were in second grade. So 6x minus 6x gives me 0 x's, right? Those are eliminated. That's why this is called the elimination method. Now negative 20y plus 6y will give us negative 14y equals 32 plus 24 will give us 56. Now, if we get to this point and we haven't eliminated one variable, so that means we're only left with one variable. If we still have x's and y's at this step, we have done something wrong. We need to go back and fix it. But we did it all right. We're all good. So there's nothing here to fix. We can move on. So now for solving for y, we need to divide by a negative 14 on both sides. And we will find that y equals a negative 4. So we have our y. But now, we know that solving systems of equations means that we have to have two answers. So that means we have a y, but now we have to go back and we have to find x. So if we go back and we find x, I'm going to draw a line down the middle so we can separate our work. We have to go back in and plug into one of our two original equations. Now, this was an original before we multiplied, and this was an original. It doesn't matter which one you plug into, just like it didn't matter before when we were working problems in the previous video. So, I'm going to pick the top one. It doesn't matter which one I pick, but I'm going to pick the top one. So, I got negative 3x plus 10y equals negative 16. Now we know that y equals negative 4, so for y, I'm going to plug in negative 4. Once I do that, I will have negative 3x plus 10 times negative 4 equals negative 16. Alright, so now I've got to multiply. So negative 3x. Alright, now we got 10 times the negative 4. So that'll give us negative 40 equals negative 16. Isolate our x, so that means we have to add 40 to both sides. So let's do that. Add 40. And that will give us a positive 24 on our right and a negative 3x. Well, all we have left to do is to divide. So we divide by negative 3. So x equals negative 8. Now, if you plugged into the other equation, you would still get negative 8. So either way, either one works. But now, we learned that we don't just write x equals a number and y equals a number. We've got to clean this up, and we've got to write it as an ordered pair. So if we write it as an ordered pair, we got that y was negative 4, and x was negative 8. So remember, we have x, and then we have y. So when we write this, our ordered pair should be negative 8, negative 4. And remember, this is our intersection point if we were to graph it. So when we solve these by graphing, this will be where the two lines intersect. Because remember, these are linear equations. They have an x, they have a y. They don't have any exponents, nothing crazy going on. So we could graph these lines using slope-intercept or choosing points and plugging in ordered pairs. So this is nothing new. You're just finding a new method to solve equations. And this would be your intersection point, or where they cross one another.